Okay, this is the practice test for Unit 11. Hopefully you've done enough practice as we've gone through and done the notes and done each practice assignment that as we go through and do these, you don't need to refer to anything. Again, you're not going to have any reference sheets on the test or anything like that. So please make sure you're getting those memorized. Again, it's not really necessary to memorize each one of the rules and say, okay, this is what happens to X and this is what happens to Y. As long as you understand what goes on, a lot of this will kind of take care of itself, especially with some practice. But you do need to have the methods memorized without using a reference sheet or anything like that. So let's go ahead and take a look at problem number 1. The instructions here say graph the image of the figure using the transformation and use proper notation. So we're going to use prime notation, of course, when we do this. So we need to know what happens with this. This is a mapping rule, so we need to know that this is going to move this to the left 4, and this is going to move it up 5. Now, you don't have to describe that, but we do need to know what happens here. So we're going to go to the left 4, and then we're going to go up 5. So 1, 2, 3, 4, 5. So we're going to put that dot right there, and that, of course, would be F prime. Then we're going to do G. That needs to go left 4, 1, 2, 3, and then up 5. So that's going to put us right here. Okay, and that's going to be G prime. And then we're going to go left 4, so over here 4, and then up 5. That's going to put us right here. So that's going to be E prime. And then all we have to do is just draw those. And does this look like it was slid back and up? It does, so we're in pretty good shape there. Let's take a look at the next one. Dilate by a factor of 1/2. So what we need to do on each one of these is multiply each one of the coordinates by 1/2. So if we need to write down what some of these are, that's totally okay. This one is -3, -1. So -3, -1. And remember what happens with each one of these is we just multiply them by 1/2, or in this case we could divide by 2. So this would be -3/2, -1/2. So this is going to be -1.5, -1/2. So there's going to be E prime. And I'm going to go with a little smaller marker here. So this is going to be E prime. This one here is -3, -3. So -3, -3. That would change to -3/2, -3/2. So if we wanted to do fractions, -1.5, -1.5. So that would be right here. So I'm going to put a D prime right there. And then this one, of course, for F is 0, -3. So 0, -3. Half of 0 is still going to be 0, and half of this is going to be -3/2. So -1.5. So we're going to go right there, and that would be F prime. Now, this is a teeny tiny triangle, but that is it right there. So just make sure you mark that and that it's in the right place. Let's go ahead and do the next one, and let's reflect across the line y equals x. So if I'm going to do a reflection, we normally like to draw the line of symmetry right here. So I'm going to go ahead and put that down. A couple different ways we could do this. We could do this using the rules. When we reflected across the line y equals x, we switch the x and y. We can also do it just graphically, like we can say, look, I need to go straight across this line. So I'm going to count that this is one diagonal box, this is two diagonal boxes. So one diagonal box to get there and one diagonal box to go past. So I'm going to mark that as L prime. If we go diagonally, again, don't go like that. Go perfectly 45. So we're going to count one diagonal box and then a half. Here's another half, and there's 1. So I'm going to put this one right here. That's going to be K prime. And then we're going to count, again, diagonal, 1, 2, 1, 2. So we're going to put it right here. So let's go ahead and mark that as J prime. Now I'm going to go ahead and fill this in, and then what we want to do is we either want to tilt our head or tilt our paper. Does that look like it's a reflection across the line y equals x? Now I've got kind of crappy writing here, but it looks pretty darn good. And if you wanted to do this, let's just double check this one right here. That original J was the point -1, 3. Well, if we switch that, again, all we have to do is switch the x and the y. So this is J prime. This is going to be 3, -1. And look where this one is, 3, -1. It's in the right place. So we're in good shape there. If it did ask you to write down the coordinates, you would have to be able to do something like that. So let's go ahead and reflect this across the line y equals -2. So y equals -2 would be right here. Okay, there's our line of symmetry. So this is 2 below. We're going to need to make sure that this is 2 above. So this is going to be L prime. This is 1, 2, 3 above. This is going to need to be 3 below. So this is going to be K prime. And this is 1 above. So when we flip it down here, it's going to be 1 below. So that's going to be J prime. So it needs to look like this. Okay. Now, again, if you rotate your paper, tilt your head totally to the side, you can see that whatever was above the line is now below the line, and whatever was below the line is now above the line. So I think we've done a pretty good job on that one. Now, a rotation of 180 degrees, rotations are a little bit more difficult. So on a rotation, if you need to write down what the coordinates are, that's totally okay. I'm going to show you another way to do this. Rotations, we rotate around the origin, so we go 180 degrees. So to get back to the origin, I would go down 2 and back 3. So I'm going to go back 3 and down 2. We're going to end up right here. It's kind of like drawing a straight line between those. So this is going to be x prime. For this one, if we go right through the origin, we would go 2 past the origin right over here. So this is going to be v prime. And then again, to go to the origin, we would go down 4 and back 1. So we're going to go back 1 and down 4. It's kind of like just reversing the two of those. And we end up with this. So this ends up being w prime right here. So our new figure, our image of the pre-image, looks like this. Now, if you'll notice, this does look like it's rotated 180 degrees, but I do want to show you, remember the rule for this is xy changes to, remember what happens with this when we rotate it about the origin? The x and the y stay in the same place, they just become opposites of each other. So let's take this one right here. This point right here is 1, 4. So w is 1, 4. Well, if we were to switch that, it stays in the same place. We just change the sign. So this would be -1, -4, back 1 and down 4, and there it is. And you can do that with each one of those. Okay, so don't forget the rules can be useful if you get stuck or something like that. Always go back to those. Now, a clockwise rotation of 90 degrees. Rotations, again, those can be tough. Especially the 90-degree ones. Those are really tough. So here's what I like doing. Remember, the rule is if we've got xy and we want to do a 90-degree rotation, remember, on 90 degrees, they do switch places. But because it's clockwise, it's the x that changes sign. So here's what I'm going to do. I'm going to list each one of these. So I'm going to list E, F, and G. So E and F and G. So here's what we're going to do. E is 4, 1. F is 1, 3. And let's see, G is -1, 1. And remember, what we do is we switch places, and the x gets multiplied by a negative. So I'm going to put a -1 out here. Or you could just, if you wanted to, I suppose you could just put a negative, but you got to make sure that it's clear that you're multiplying that. So here's what E prime is going to be. We're going to switch them. This is a 1 and this is a 4, and we multiply that by a negative. So there we go. So F prime is going to be, we switch them, and when we bring this one over here, we make it the opposite sign. So careful on G prime, because remember, we're multiplying by a negative over here. So we multiply by a negative, and we just change there. So the 1 comes over here, and when we do a negative times a negative, we get a positive. So G prime is 1, 1. Okay, so that's going to go right here. So there's G prime. F prime is 3, -1. So 3, -1. So here's F prime. And then E prime is 1, -4. So over 1 and down 4. 1, 2, 3, 4. So about right here. So here is E prime. So here is the image, and here's what we're hoping. Does that look like we rotated it about the origin? And again, one way to check this is you can say, hey, look, if I were to draw a line from the old point to the new point, so this is the old one and this is the new one, did we rotate 90 degrees? And it sure looks like we did. So I think we're in good shape there. Okay, let's slide down here and let's talk about these guys. This one says, given the pre-image ordered pairs, write the image ordered pairs for each transformation. So this is where we're going to need to work a little bit, because if we've got a drawing, if we've got a graph, then that tends to make it a little bit easier. So what we want to do here is we want to reflect it across the x-axis. Now, if you need to refer to something, you're welcome to refer to something, but by the time you take the test on this, you got to make sure that you got these memorized. So let's think about this for just a second and see if we can remember what happens here. If we reflect this across the x-axis, what we do is we take a point up here and we reflect it down here, or down here and we reflect it up here. So the x-coordinate doesn't change at all, it's the y-coordinate. So what's going to happen here is we're going to take our old xy pairs, and we're going to, if we reflect it across the x-axis, the x stays the same, it's the y-coordinate that changes sign. Now, I've got a little cheat sheet over here. Let's just check and make sure we're reflecting across the x-axis, and look what happens. The x stays the same, and it's the y coordinate that changes. And then again, remember some of these other ones right here. We may come back to that a little bit later. So we're going to bring this straight down, and we're going to bring this one down, and we're going to multiply by a negative. Okay, so the x and y stay in the same place. It's the y coordinate that changes. So we're going to have a prime here, negative 5 comma negative 1. S prime here, negative 5 comma negative 3. U prime, 0 comma negative 2. And that's it. That's all you have to do. No drawing, no pictures, no graphing or anything like that. We're all set. Okay, on this one, we're going to dilate by a factor of 4. So remember, when we dilate, we're going to multiply it by whatever that number is, whatever the scale factor is. So a dilation of 4 means we're going to have a scale factor of 4. We're going to take each one of the coordinates and multiply them by 4. So G prime is going to be 8 comma negative 12. Did I do the math right there? Yep, multiplying them each by 4. So A prime is going to be 12 comma negative 4. And B prime, let's see what that would be. Multiply by 4, so we get 16, and multiply by 4, we get 4. So there we go right there. Okay. Again, in some respects, that's almost easier. Okay, reflect across the y-axis. Now remember what we set up here. When we're reflecting across the axes, the x and y get to stay in the same place. So we've got an x and a y here. But what we're going to do is we're going to take the y-axis is the line of symmetry. We're going to take everything on the right, move it over here, everything on the left, move it on the right, and everything on the right, move it on the left. Well, the y coordinates don't change at all. It's the x coordinate that changes. So we're going to bring this straight down, and we're going to multiply by a negative. So we're going to do m prime is going to be negative 2 comma 2. J prime is going to be negative 2 comma 4. And then A prime is going to be negative 5 comma 1. Okay, so there we go with those 3 points right there. So on number 10, we've got a 90-degree counterclockwise rotation. So let's see if we can remember what goes on here. Remember, with those 90-degree rotations, we're going to take the x and the y, and what happens is they switch places. So this is going to be y comma x, but one of them has to change sign. So the way I remember this is I kind of like clockwise better than counterclockwise, because that's kind of what we typically do, go to the right like a clock does. And I like x better. So x was the one that changes sign on the clockwise rotation. On a counterclockwise rotation, it's going to be the y that changes sign. So here's what we're going to do. We're going to go this way and this way. We're going to crisscross those, and this one gets multiplied by a negative. It's the y when it comes over here, it gets multiplied by a negative. So r prime is going to be negative times a negative. That's going to be a 5. That stays a 1. So p prime on this one, we're going to multiply by a negative, which doesn't change that at all. So that's going to be a 0, and that one stays the same. And then again, coming over here, we multiply by a negative. So I prime is going to be 5 comma, and then of course this is just a 3. So let's go ahead and circle that one. Okay, so we haven't really referred to the notes except for kind of confirming our answer there. Oh, and here's a clockwise rotation. So again, on that one, this is the one that we were talking about just a second ago. They do switch places. So they do switch places, but the x is the one that changes here. So we're going to go like this and multiply by a negative and then switch places right here. So we're going to have a p prime. So this is going to be a negative 5 comma negative 1. And n prime here, again, if you've got to draw the lines, that would be totally okay. So we're going to have a negative 1 here, and that would be a negative 1. And then for k prime, again, multiplying here, that's the one that changes, so that's going to be a negative 5, and of course that stays exactly the same. So we're going to end up with a negative 2. So there are the 3 points, the 3 new points with that prime notation right there. Okay, let's take a look at a reflection across the line y equals x. Remember, that one is kind of interesting because all that happens on that one is they just switch places. That's literally it. If you reflect across the line y equals x, they switch places. So this is going to be a y comma x. You might want to remember what happens if it were a negative x, if it were y equals negative x. I think on that one they switch places and they switch signs, but let's just double check here. So we're doing reflections. Yep, they just switch places, and for reflection across the line y equals negative x, they switch places and switch signs. Okay, so let's come down here. All we need to do is just switch places, so we're literally just doing this, crisscrossing these on each one of them. So t prime, negative 3 comma negative 4, v prime, 1 comma negative 5, and p prime is going to be 1 comma negative 4. So we'll go ahead and circle that, and we are all set. Okay, done with the first page. Let's go on to the next one. We've got some interesting problems here on the next page. It says write a verbal description for the transformation, then write a mapping rule. So you'll notice on these, we've already got the old one and the new one. Good idea to go ahead and put that down. This is the old and this is the new. Please don't mix that up, because if you do, whoops, I've got that backwards, or I wrote it twice. So this is going to be old here and this is going to be new here. If you do mix it up, you're going to get things going the wrong direction, whether it's a translation or a rotation or something like that. So on this one, you'll notice that all we did is we took this kind of like on a placemat and slid it over here. So that means we went left 1, 2, 3, 4, and then up 1. So translation, and we're going to go left 4, up 1. And the rule for that would be go left, we got to go minus 4, and then y plus 1, okay? Description on this one right here, so let's take a look. This is the old one, this is the new one. Notice these are right across from each other, those are right across from each other, kind of over here. So what we've got here is we've got a reflection across the line, y equals negative x. So reflection across y equals negative x. Okay, now remember what the rule was for that. If it was across the line y equals x, they just switched places. If it was across the line y equals negative x, they switched places and they went to the opposite sign. So this is going to be a y and an x, and we're going to put a negative in front of each one of those. Okay, let's take a look at this one right here, see what went on here. Again, this is, don't mix these up, this is the old one and this is the new one. You can tell because of the prime notation. So here is J and here is J prime. So it used to go like this and now it goes like this. So you can see this is a 90-degree counterclockwise rotation. So let's do 90-degree counterclock rotation. We could add about the origin, but I think we all know that. Okay, so again, the rule here was, remember what happened on this because we did one of these on the other side. We switched the x and y, so this is a y and this is an x. And remember, if it's clockwise, the x changes sign. If it's counterclockwise, the y changes sign. Okay, so I think we're good there. Let's take a look at the next ones. Same rules as above, same instructions. So what we want to do here is we want to describe what happened on this. This is clearly a dilation. What happened here is they shrunk this, but we want to figure out some nice points to use. So a nice point to use would be C and C prime, because the coordinates of the old point, again, this is the old and this is the new. This got smaller, and remember we use new coordinate over old coordinate. Okay, don't flip that over because you'll get the wrong answer. So this is negative 4, 0, and this is negative 2, 0. So the new coordinate is negative 2, the old coordinate is negative 4, so this would be a shrink of 1/2, a dilation factor 1/2, or you could put 0.5 if you wanted to. Either way there is fine. And then to write the rule for that, we just write 1/2 x, 1/2 y. Now we're not going to be doing any where we mix the two of them so that we get a different scale factor for the x than we do for the y. But just to double check here, let's check and make sure this one right here, this is negative 1, 4. So if we shrunk that by a factor of half, this should be negative 1/2, 2. And let's just make sure that negative 1/2, 2, yep, that works out just fine. Okay, let's take a look at this one. Again, we've got old here, we've got new here. You can tell because of the colors on this screen and also because of the prime notation. You'll notice that they're oriented the same, and all we've done really is just slide things around a little bit. So I'm going to slide this over here. We're going to go over 2 and up 6. So this is a translation. And that was right 2 and up 6. So we're going to do x plus 2 and we're going to do y plus 6, and we are all set there. And then take a good look at what happened here. These are kind of funky to look at. This is not a reflection. We didn't slide this around. This is a rotation. Now take a look here. Again, this is the old one and this is the new one. If I draw a line from the origin to that old S and a line from the origin to the new S, we've rotated this way 90 degrees. And if you wanted to do a double check of that, there's another easy point to check, and it would be T to T prime. And look at that, there's a 90-degree angle right there. So this is 90 degrees in this direction. Of course, that is clockwise. So 90-degree clockwise rotation. about the origin. So I'll write about origin, just to remind ourselves occasionally. And then the rule for a 90-degree rotation around the origin was, remember, we switched the x and the y, and the x gets multiplied by a negative. Okay, let's slide down here and see what we've got on this, the last of this page. It says, draw and write an equation for the line of symmetry. So all we have to do is we just have to draw the line of symmetry and then write an equation for it. So what's good to do is, remember, we normally only have those 4 lines of symmetry, the x-axis, the y-axis, y equals x, and y equals negative x. If we were just to picture those right away, you can automatically eliminate the y-axis and the x-axis, because the right doesn't look like the left, top doesn't look like the bottom. You can also eliminate the line y equals x because that side of the line wouldn't look like this side of the line. But look at this right here. We've got the line y equals negative x. So I'm going to do a better job of drawing that here. So we're just going to draw that in right there, and we're going to say y equals negative x. All we had to do is draw it and write the equation for it. This one, it's not the x-axis and it's not the y-axis, it's not this one and it's not this one, because if you'll notice, the line of symmetry is right here. So it is the line y equals 1. Remember, don't mess that up. A horizontal line is always y equals a number, and then a vertical line is always x equals a number. And a vertical line is what we've got right here, straight up and down right there. That would be x equals 2 on that one. Okay, so x equals a number is vertical like this, and y equals a number is horizontal like that. Okay, all right, we're a little more than halfway through. Let's take a look at the next page. And on this next page, it's similar to the last ones that we did, except for it says draw the line of symmetry between the preimage and the image, write an equation for it, then write a mapping rule for the transformation. So we've got to do one extra step right here. We've actually got to write the mapping rule on this one. So this one's pretty easy to see. You can see that the line of symmetry is x equals 0. In other words, it's the y-axis. Okay, we could say either one there. And remember what happens with these. What we do here is the y-coordinate stays the same and the x-coordinate changes because we're flipping this horizontally. So this is going to be negative x comma y. Line of symmetry on this one, hopefully we're pretty good at seeing these right away. So this would be the line y equals x. Again, tilt your head to a 45 degree to the right. And remember, on those, all that happens is we switch the x and y. So this is going to be y comma x. And then the line of symmetry right here is this line right here. It is the line y equals 0, or again, another way to say that would be the x-axis. And the rule for flipping things across the x-axis, for using that as a line of symmetry. Well, remember, when we do that, the x and y stay in the same place. So like this x-coordinate is the same for c and c prime. The only difference is instead of going down, we go up. So what we do is we change the sign on the y. Okay, because we're flipping this vertically, so to speak, whereas this one we're flipping horizontally. Okay, let's come down here and take a look at the next couple. It says, use the graph to draw a dotted version of the new figure after each transformation. When you're done with the composite transformation, shade the final figure and after the entire composite transformation is complete. Okay, so here's what we need to do. We need to take that figure right there and we want to reflect it over the line, so we should probably just say this, over the x-axis. So let's go ahead and reflect this over the x-axis. So reflecting over the x-axis, we're 4 above, so we're going to be 4 below. And we're 4 above, so we're going to be 4 below. So this is what it's going to look like. Okay, that's the shape that we're after. Okay, then we want to translate this up 3 units and left 5 units. Now it does say to do this kind of one at a time. So we're going to go up 3, 1, 2, 3. So we're going to be right here. 1, 2, 3, we're going to be right here. And then 1, 2, 3, we're going to be right here. So it looks like this. Okay, and then the last one, translate this left 5 units. So we're going to go left 5 units, and I'm going to change to blue because this is the last one. So we're going to go 1, 2, 3, 4, 5. So we're going to put a big blue dot right there. 1, 2, 3, 4, 5 right there. And 1, 2, 3, 4, 5 right there. So we'll connect those, and then we'll shade that in, and we'll take a look at it, and we'll say, you know, even though my drawing is kind of bad, are these congruent? Well, the answer on that is yes. And if we had to explain our answer, we could do it lots of different ways, but probably the easiest thing is we could just say no dilations. No dilations. Those are the things that would change the size and the shape, and we didn't do any of those, okay? So we're going to come down here, and let's take a look at the next one. This is number 26. Dilate by a factor of 2. So that means we want to make everything twice as big as it used to be. Well, twice as big as 0, 0 is still 0, 0. Twice as big as 0, negative 4 would be 0, negative 8. And twice as big as 2, negative 4 would be 4, negative 8. So 4, negative 8 would be right here. So we'll go ahead and draw a dotted line here. And the cool thing about this is you can see that because we have a scale factor here of 2, we've basically made this the same shape, it's just twice as big. Okay, so we've got a similar shape right here. It's no longer congruent. So we already know the answer to that one. And then it says reflect over the line y equals x. So if we reflect this across the line y equals x, remember what's going to happen is the x and y coordinates are going to change. Well, the interesting thing is 0, 0 stays 0, 0. Let's see, this is 0, negative 8. So if we flipped 0, negative 8, that would be negative 8, 0. So negative 8, 0 would be right here. And this is 4, negative 8. So we would have negative 8, 4. So negative 8, 4 would be right here. So this is the new shape. Okay, there's our new figure after we do that reflection across the line y equals x. And then we've got a translation up 4 units. So we're going to take this. This is the last one. So we're going to go up 4 units. 1, 2, 3, 4. So we'll be right here. 1, 2, 3, 4 right here. And 1, 2, 3, 4 right here. So that is our new figure. Go ahead and shade that in. Okay. Now, are the figures congruent? No way. And we could tell that at the very beginning. And we can say this. Dilated by factor 2. And we could also say something like this. It's twice as big. We could say this. It's also similar. It is a similar figure to the original one. It's just not congruent. The angles would be the same size, but the sides are not the same size, so it's not congruent. Okay, let's take a look at the last page. Okay, so on this last page, on 27 through 29, we've got a lot of these figures again where you need to match each of these composite transformation images with the correct shape and orientation. So here's our pre-image over here, and then we're asked to do a couple of these composite transformations and then figure out which one of these would be the right one. And clearly we've got a whole bunch to choose from and only 3 problems, so we're going to have some extras here. So let's take a look at number 27. It says, reflection over the line y equals x, then translated right 4 and down 1. Okay, so let's take a look here. I'm just going to draw enough of this line that we can kind of see what's going on there. And then we're going to reflect this across the line y equals x. So remember, we just switched the x and y coordinates. Or graphically, what we can do is we can say, look, this point is on the line, so that's going to stay there. And then this is half a diagonal unit away from it, and that point's going to reflect over here. This one is 1.5 diagonal units away, so there's another half and there's a 1, so that's going to go right here. Let's move to this one. This is 1 diagonal unit away, so there's another diagonal unit right here. So this one is 1.5, so there's our half, and there's another one right here. And you can kind of see this shape coming together here. There's a diagonal, and there's a half. So here's another half, 1 and 2, so we end up right here. So this is roughly what that shape would look like if we reflected across the line y equals x. Now, if you want to, what we can do here is let's take this point right here. So this is over 2 and up 7. So I'm going to do 2, 7. And then what I'm going to do is I'm going to use the rules. And the rules say that when you're reflecting across the line y equals x, literally all you do is you just flip the x and the y. So this is going to be 7, 2. So let's see if this outer corner of this L shape ends up over here. So let's go over 7 and up 2. It does end up right there. So we've got the right point there. So this is what it looks like. And again, you can tilt your head 45 degrees to the right and see that that would be a reflection across the line y equals x. And then we want to translate this right 4 and down 1. So right 4 and down 1, right 4 and down 1. So here's what's going to happen. We're going to end up with an L shape that looks something like this. It's going to be right there. All right. Now, it's not important whether we graph this. It just says match it up with the composite image. So we need a shape that looks like this, and there is one. It happens to be this one right here. It happens to be F. So I'm going to go ahead and mark this one down as F. I'm going to circle that, and we'll move on to the next one. Now for the next one, I'm going to go ahead and change colors. So I'm going to change to green, and it says we want to rotate this image 180 degrees about the origin, and then we want to reflect it over the line y equals negative x, and then we want to reflect it over the x-axis. Holy cow, lots going on here. So let's see what happens here. Again, there are a couple different things that we can do. Remember, if we rotate this about the origin 180 degrees, we basically change the coordinates of the x and the y axis, or the x and the y coordinates. So we change the x to be a negative x, and we change the y to be a negative y. The rule looked like this. It was if we had an xy, then we make that negative x comma negative y. We just change the sign of each one of those coordinates. So here's what we're going to do. I'm going to take this one right here, and we would change this so that this is negative 2 comma negative 7. So back 2 and down 7. That would put us right here. Now what I want to show you is we could do this relatively quickly looking at the graph by saying, look, to go through the origin and end up at that point right here, if I go down 7 and back 2, I'm going to go back 2 and down 7. So for this one right here, if I go down 3 and back 2, I'm going to go back 2 and down 3. So I'm going to end up right here. And this point right here, I'd go down 3 and back 3. So I'm going to go back 3 and down 3. So I end up right here. On this one, this is going to be, let's see, I have to go down 7 and back 4. So I'm going to go back 4 and down 7. So I end up looking something like this. If I did every single one of those points, either by using the rule or by kind of drawing that line through the origin and kind of going back through the origin and getting to where we need to be, this is what we'd have. Then we want to reflect this over the line y equals negative x. So I'm going to draw the line y equals negative x. I'm going to try and do that as nicely as I can. All right, so we're going to go through those points right there. And then what's going to happen here is, again, for the line y equals negative x, here's what we do. We take every xy pair, and remember, if we're reflecting across the line y equals x, we just switch the x and the y. But if we're reflecting across the line y equals negative x, we do y and we do x, and we change the sign of each one of them. So remember this point right here that was, it ended up being negative 2 comma negative 7. Well, what we would do here is we would switch each one of these. So this would be a negative 7. And this would be a negative 2, but then we multiply each one of them by a negative, so what ends up happening is this is 7 comma 2. So 7 comma 2. All right, so over 7 and up 2, so we end up right there. Well, that's kind of interesting that's on this little dotted line or dotted figure that we already drew. So here's what we're going to do. We already did this one, so let's do this one right here. So this is negative 4 comma negative 7. So that would be, we'd have a 7 and a 4, because remember, we're going to switch them and we're going to change the signs. So we're going to have 7 and 4, and lo and behold, look what we're going to end up with. It's going to end up being this same shape right here, okay? All right, so we've got those two taken care of, and then we want to reflect it over the x-axis. So when you reflect it over the x-axis, it's the y-coordinate that changes. So if this is 2 above the x-axis, this is now going to be 2 below the x-axis. If this is 4 above the x-axis, it's now going to be 4 below, 4 above, so 4 below. This is 3 above, so 3 below. 3 above, so 3 below, and 2 above, so 2 below. And notice what we have here, we have this shape right here. Now, it's not terribly important that we got this perfect or that it looks right, because all we need to do is match it up with one of these here. So let's see which one this is. It looks like this right here, so that is D. It looks like D right there, so I'm going to put a big fat D right there, and I'm going to circle that. Okay, now we're going to go to the last one. On this one right here, it says we want to reflect over the y-axis, and we want to do this twice. So if we reflect this across the y-axis, we're 2 to the right here, so we're going to go 2 to the left here. We're going to go 4 to the right here, so we're going to go 4 to the left here. Again, what we're doing is we're just saying, look, I'm 2 units to the right of the line, so now I'm going to be 2 units to the left of the line. 4 units to the right of this line of symmetry, so I'm going to be 4 units to the left. Same thing here, and then same thing here. So here's what we end up with. We end up with this shape like this. So we end up with a mirror image, it's just pointed the other direction. Now, what we did is we flipped this over here and flipped this over here, but now we need to do the same reflection over the y-axis, but we need to do it in the other direction. So we went from here to here. Well, now we're just going to go back, and we went from here to here, and we're going to go back. So we end up getting right back to the exact same shape. So where is that? That is A. So I'm going to put a big fat A right here, and then we're going to come down and we're going to take a look at the next couple. Now, the last part of this practice test, it talks about the triangles, the congruent triangles, and the theorems. So we've got side, 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 angle, side, angle, angle, side, and then angle, side, angle. So it says state that they're congruent, and state a congruence theorem, and then if not, just say there's not enough information. So let's go ahead and take a look at this one right here. Remember, there is some additional information right here that side is congruent to itself. So we have angle, side, angle, and going here we have angle, side, angle. So yes, those would be congruent, and we can use angle, side, angle congruence theorem to state that. So we're in good shape there. Let's take a look at this next one. Again, we've got some understood hidden information right here that side would be congruent to itself. So let's take a look at what we've got here. We have an angle, and then we have a side, and then we have another side right here. So we have angle, side, side on this one, which we know we need to be careful with on this. And then if we look at this other one, we have side, angle, and side. So here's the deal on this one. That angle right here that we know is congruent is not in the right place for the two of these. It's in a really precarious place on this one, angle, side, side. We know we've got issues with that right there. And then we've got angle, side, angle, side on this one. So these just flat do not match up. There's not anything else that we can say about this one because there aren't any parallel sides or anything like that. So what we would say is not congruent, and we just leave it at like that. There's not enough info on this one, so not enough info there. All right, let's take a look at this one. Again, immediately what we notice is that we have some vertical angles, so I'm going to go ahead and put two arcs right there. And then what we've got here is we've got angle, angle, side, angle, angle, side. We don't have the side that's included, but that doesn't really matter because as long as we have angle, angle, we automatically know that third angle would have to be congruent. So we can say that these would be congruent, and they'd be congruent by angle, angle, side. So we've got that one there. And then let's take a look at the last one. And of course, we've got side, side here with the two hatch marks here, three hatch marks on that one, so we can put one here. So these would be congruent, and they'd be congruent by side, side, side. All right, now let's take a look at these next four here. They've all got the same instructions. It says, state what additional information is needed to state that the triangles are congruent using the given theorem. Okay, so what additional information is needed here? So we need to do angle, angle, side on this one. So if we want to do angle, angle, side, we've got this side right here. They're even oriented the same way. Well, what I'd need is I'd need these two angles to be congruent so that I could have angle, angle, side. So what I'd need is I'd need angle T to be congruent to angle J. That would make it okay. Or, and I'm going to put a big fat or right here, we could also go the other way, okay? So we could go this way, angle, angle, side, angle, angle, side. So what I'd need here is that angle S has got to be congruent to angle K. So either one of those would be okay there to show angle, angle, side congruence. Now for angle, side, angle, let's see what we've got on this one. We know that those are vertical angles, so I'm going to go ahead and do those. And when we do angle, side, angle, it's got to be the side that's included between the two angles, so it's got to be this one right here. Unlike this one where it's angle, angle, and then the non-included side, this one has to be the side included. So this one has to be IU, has got to be congruent to, if we do IU here, we want to do TU on this one, okay? So that's the information that we'd need there to show congruence using that theorem. And then on these guys right here, this is side, angle, side, so let's take a look. Side, angle, side. So we have a side and an angle. We would need this side right here. I'm going to put two marks there. Let's see if it matches up with over there. Side, angle, and then this side over there. Yep, that would be okay there. So what we need is we need side, we need side VW. We need that to be congruent to, if we do VW, we're doing one arc to no arcs, so this would be RQ to keep those in corresponding order there. That's what we'd need for that theorem. And then for side, 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 again, we know that those are congruent because that SQ is congruent to itself. What we need is RS to be congruent to US. So we're going to say we need RS to be congruent to US. So US right there. And again, let's make sure, yeah, that is in corresponding order. So that's what we'd need there. Now, this last little bit, the instructions are a little longer. It says each diagram has missing information that is not indicated, which may or may not make the triangles congruent. State what the missing information is and decide whether the triangles can be proven congruent using the given theorem. So let's take a look at this one right here. So there is some missing information right here. Right now we've only got marked that these two sides are congruent and those two sides are congruent, but we automatically know that those angles are congruent to each other. So you might be tempted to say something like this, like angle C is congruent to angle C, but that's really kind of a tough way to write it because it's involved in both of them, or you could be talking about this angle on the outside, which you probably aren't, but we probably ought to be more specific. So let's say this. Let's say angle BCA, so angle BCA is congruent. Now we want to say this other one in the right order. So we did 2 to 1 arc to 2 right here. So sorry, we did 1 hatch mark to 1 arc to 2 here. So 1 hatch mark to 1 arc to 2 here. So we want to say DCE. So angle DCE. Okay, so this is the information that we would have to show that those are congruent. And now we have side, angle, side. So yes, those are congruent. So the answer on this one is yes, they are congruent by side, side, side. Okay, on 39, this one's a little bit tricky. So if you take a look at this diagram right here, they want us to show that GHF, so GHF is congruent to HGL, so HGL, by angle, angle, side. Now there is some missing information on here, and the missing information right here is that these sides, GH is congruent to GH. So I'm going to go ahead and mark that GH is congruent to GH. That's the missing piece of information that we get right there. Now the question is that enough to say that the two of these are congruent? Well, again, just like we mentioned before, you might recognize this diagram, but now it has some letters marked on it for the points, for the vertices. So on this one right here, we have angle, side, and then a side over here. We don't know anything about this angle right here. So we've got angle, side, side. And then on this one, we have side, angle, side. And nothing on this matches up. We don't know anything about any of the other angles. So that extra piece of information doesn't give us enough that we can say angle, angle, side. Now, if we did have something like this, if we were to come over here and say something like, hey, we've got these two angles right there. If somebody were to come along and say, hey, this extra information that you needed was that those two were the same, or that those two angles were the same, then we'd have enough information right here. But as it is right here, we can't say that these are congruent. So what we're going to say is not enough info. Okay, again, these are not congruent. Okay, not congruent triangles. Not congruent triangles. Okay, so that's what we'd say on that one. And then we'll take a look at this last one right here. They want us to show that triangle NMP is congruent to triangle PQM by side, side, side. Well, the extra information that's missing on this one is, of course, this right here. They share this side right here, so we'd say that PM is congruent to PM. And is that enough to say that they're congruent? Well, the answer to that is yes. We can definitely say those are congruent by side, 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 because we've got one here matching with one here, two here matching with two here, and then, of course, that third side is congruent to itself. All right, so a couple of tricky ones right there, stuff to think about. Really good stuff to practice. Make sure you look at these over and over. Of course, the test is going to be shorter than this, but any of these types of problems could definitely crop up on the test. All right, good luck.